now this is the last video that we'll do. This is factoring using grouping. And first of all, I want to just look at the big factoring strategy. This strategy covers everything that we will do for the rest of the semester. It will always consist of these 4 steps. First step is to always factor out the greatest common factor. That's going to be something that you are going to be tempted to forget to do because you'll be in the middle of learning the other processes, but you need to always remember to factor out the greatest common factor first. The next thing you do is you look at how many terms there are. If there's 2 terms, then the only thing you can do is special forms. That's lecture 25. If there's 3 terms, then you might do special forms, which is lecture 25, or the AC method or the diamond method, that's lecture 24, or guess and check, which is lecture 23. So we're not doing any of that stuff yet. If there are 4 terms, then I will do grouping. That's what we're getting ready to do. Then we'll see if it factors any further. Again, that's lecture 25. And we can always check our answer by multiplying. So that's why the things in red are the things that are in this lecture. The grouping steps are, first of all, factor out the greatest common factor. That's not technically a grouping step because we should have done it before we ever got to the grouping step, but I just don't want you to forget. Then we'll group, find the greatest common factor for each group, and then factor out a binomial if possible. That probably doesn't make sense right now, but hopefully it will when we look at our next example. Again, the grouping steps will be on every slide, so don't worry about remembering them yet. You'll want to remember them eventually. But if we look at this, the first thing I want it to do is say, is there a greatest common factor? Now it looks like there might be an x. Oh, but the last term doesn't have an x. Is there a y in everything? Nope, the first term doesn't have a y. There's a 4 in a couple of things and a 3 in a couple of things, so there is no greatest common factor. The next thing I do is I look to see how many terms there are. I have 4 terms, so that means that I'll do grouping. So I will group the first 2 things together and group the second 2 things together. You'll notice in the list of steps it says please don't use parentheses. In this problem, parentheses would not have thrown you off. But parentheses will throw you off once you get positive and negatives in there. So please just don't even start the habit of grouping with parentheses. If you don't want to use the curly brackets, that's fine. Use a colored highlighter or just do a swoop under it or something, but don't use parentheses. Okay, now we look at each group. So if we're only looking at the first 2 terms, the first pair, is there anything that those guys have in common? They both have an x squared, so we could factor an x squared out of that first group. What about the second group? What do those 2 things have in common? They both have a y squared, so I could factor an x squared out of the first group and a y squared out of the second group. If I factor the x squared out of the first group, I factor x squared out of 4x cubed. What am I left with? The 4 will stay behind and one of the x's. Good. Now what if I take an x squared out of 3x squared y? Well, the only thing left is the 3 and the y. So I'd be left with 4x plus 3y. Take a second and double check it in your head. X squared times 4x? Yes, that's 4x cubed. X squared times 3y? Yes, that's 3x squared y. So I've done it correctly. Now for the next ones. Okay, if I take a y squared out of the first term in that pair, I'm left with 4x. If I take y squared out of 3y cubed, I'm left with 3y. Take a second to double check. Y squared times 4x? Yes, that's 4xy squared. Y squared times 3y? Yes, that's 3y cubed. So I make sure I've done it correctly. Now what do you notice about these? First of all, how many terms are there? Now there's just 2 terms. We used to have 4 terms, but now we have 2 terms. The x squared times 4x plus 3y, that's all 1 term. The y squared times 4x plus 3y, that is the second term. So I have term 1 is the first half, and term 2 is the second half. Is there anything that those 2 terms have in common? Yes, they each have the 4x plus 3y. Since they each have that, I can factor it out. What am I left with from the first term? Just left with the x squared, and I'm just left with y squared from the second term. So that is how it factors. How would you check? We'd simply FOIL it out. So if we FOIL it, we get 4x cubed plus 4xy squared plus 3x squared y plus 3y cubed. Is that the same thing? Yes, the terms are in a different order, but it's still exactly the same thing as what we started with. So it does check, and we know that we did it right. Okay, let's do the next one. Pause the video, please, and do this one on your own. Okay, so first thing we do, there is no greatest common factor. So I will group. I'm not using parentheses to group. What do the first pair of things have in common? They both have an x. What do the second pair of things have in common? They both have a 7. So I factor x out from the first pair and 7 out from the second pair. If I factor x out of the first pair, what am I left with? Factor x out of xy, I'm left with a y. Factor x out of xz, and I'm left with a z. So I have y minus z. Again, take a second and double check. X times y is xy minus x times z is xz. Okay, it checks perfectly. Now if I factor 7 out from the second pair, I'm still left with y minus z. 7 times y is 7y minus 7 times z is 7z. So again, that one checks. Now a very important thing to note is I'm not done. I am not done factoring until I have a string of things multiplied together. Right now I have two things added together. I have two terms. I have to keep going until I have a string of things multiplied together. Now, in grouping, you cannot keep going if the stuff in parentheses doesn't match. You can't keep going unless you have a matching binomial, unless you have a binomial to factor out. If the stuff in those parentheses doesn't match, you need to stop and figure out something different. Maybe you've made a mistake, maybe you need to factor out a negative, or maybe you need to change the order of your terms. But you cannot keep going if your parentheses don't match. But here, my parentheses do match. So I factor out that y minus z. I'm left with x plus 7, and I would check it using FOIL, and it will check just like before. My terms are in a different order, but they are exactly the same. All right, let's do our third example. Again, pause the video and do this one on your own. There are a couple of things that I need you to be careful of on this one. There's actually two things I need you to be careful of. All right, now that you've at least made an attempt, there's no greatest common factor. So I go on to the next step. There are 4 terms. As soon as I see 4 terms, I know I need to group. So I group the first 2 and I group the last 2. Okay, what's common to the first 2? P. What is common to the second 2? 3. So if I factor P out from the first 2, this is the first place to be careful. What am I left with? I factor P out of 2P squared, so I'm left with 2P. I factor P out of P. What am I left with? 1. Do not forget your ones. That's a very easy place to make a mistake, but you can't do it, so just be really, really careful with ones. Now, if you're doing your little mini checks along the way, you're going to catch yourself if you left out that one. Because when you go through and multiply p times 2p, that gives me 2p squared. If that 1 wasn't there, then there would be no way of getting that negative p up in that first pair. That negative 1 has to be there, so you can say p times negative 1 gives me negative p. All right, now I'm factoring out a 3. I've learned my 1 lesson, so I'm left with negative 2p plus 1. Now those don't match, so let's make sure that I've done it correctly. 3 times negative 2p is negative 6p, that's right. 3 times 1, that's 3, that's right. But my binomials don't match. Don't keep going. If the binomials don't match, you've got to figure out something different. Now look at those binomials. They don't match, but are they pretty similar? Yeah, in fact, they only differ by a negative sign. We could have anticipated this because if you look at that second pair, it has a leading negative. Do you remember what to do when you have a leading negative? If you have a leading negative, you always factor out a negative. So instead of factoring out p from the first pair and 3 from the second pair, I'm going to factor out p from the first pair and negative 3 from the second pair. Now I'm left with 2p minus 1 from the first pair. Factoring out a negative 3 leaves me with 2p minus 1. Be careful with your signs. If you put 2p plus 1 there, you would catch it when you did a little mini double check, because negative 3 times 2p is negative 6p. If you had negative 3 times positive 1, that would have given you a minus 3 on the end. We need the negative 3 times a negative 1 to give us the positive 3. Now my binomials do match, so I factor it out and I get 2p minus 1 times p minus 3. And again, I would just FOIL to check my work. So just be aware of your ones, be aware of your signs, and be aware of when you'll need to factor out a negative. Okay, here are some other problems. Just pause the video. I'm not going to go step by step through these solutions, but they will appear on the screen. So just pause the video so that it moves at your own speed.